Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE chemistry exothermic and endothermic reactions. And today I will give you an introduction on these concepts. I will tell you what those reactions are, I'll give you some examples, and I will explain some of the common uses of exothermic and endothermic reactions. Now, this is just an introduction. I will be making more videos on this topic, so stay tuned. If you want to know more about this, stay tuned for future videos. However, without further ado, let's get started. So, here we go. So, first of all, we need to take into account that whenever we have a reaction, whatever reaction it is we're talking about, we will essentially be rearranging the chemical compounds. That's all we'll be doing. So we'll be, for example, here we have two red molecules and one green molecule. And then at the end of that reaction happens, and then at the end of that reaction we have red molecules connected to the green molecule. So essentially we have reshuffled the molecules, the arrangement of molecules. Now each such arrangement has different stored energy. Chemical compounds store energy in them, and each such arrangement will have different amount of energy stored, because each arrangement requires different bonds and different strengths of bonds, which in turn contain energy within them. So when we break bonds, we release energy. When we reform bonds, we take up energy again. And sometimes when we have those reactions, the energy stored in bonds at the beginning of reaction doesn't always equal to energy stored in the bonds at the end of the reaction. So what does this mean? Well, energy, as we know, energy cannot be created nor can it be destroyed. It can only be transferred. So for example, here we start with more energy and here we end with less energy. So we transferred some of that energy we had at the beginning to molecules at the end. We have transferred some of that energy, but we didn't transfer all of it because we have less energy stored at the end of the reaction. So what happens to the rest of the energy? Well, it is transferred to surroundings. And that is an example of an exothermic reaction. Exothermic reactions give out energy to surroundings, whereas endothermic reactions take in energy from surroundings. Now, we can remember this a bit because if you know exo means outside. For example, exoskeleton is a skeleton on the outside, so insects would have exoskeletons. Whereas endo means inside, so exothermic reactions spit energy outside. So they give energy to surroundings, whereas endothermic reactions, they take in energy from surroundings to meet that energy demand at the end, which is greater than what it was at the beginning. So let's look more into exothermic reactions to start with, and then we'll move on to endothermic reactions. So first of all, like I said, exothermic reactions give out energy to surroundings. Now, because exothermic reactions give out energy to surroundings, those reactions will have some visible and often measurable signs. Most of the time, exothermic reactions will just give out heat. For example, we can feel the surrounding of the reaction getting warmer, or we can feel the beaker getting warmer where the reaction is happening. However, there are other things that can happen. Light can be given out. That's the common one, and sometimes even sounds can be given out during reactions. So here are some common examples. So first one is combustion. Combustion is a very exothermic reaction, and it has many uses nowadays, and it exerts a lot of energy on surroundings. I mean, it exerts it's passes lots of energy in surroundings. So for example, here we have a matchstick burning. So as we can see, that will provide heat as well as light, because we can see the flame, which is actually a source of light. In car engines, combustion will lead to actually kinetic energy. It will lead to movement, pushing the pistons. And another example is neutralization of acids and alkali. And here we will most likely just notice change in heat. So the beaker will warm up, essentially. That's how we can tell neutralization is happening. And oxidation reactions often end up being exothermic reactions. For example, if here I drew it like that, but for example, a good example is magnesium. If we burn magnesium, we are essentially oxidizing it. We are supplying oxygen to it. And if you've ever seen magnesium burning, it gives out really intense light. So it gives out heat as well as light. So as you can see, exothermic reactions give out energy to surroundings, and they can give them out in more than one form. They are most likely heat, but there can be other ways that these reactions give out energy to surroundings. Now, what are the uses of exothermic reactions? Well, I mean, there are so many uses. Exothermic reactions are the most common reactions that we see in everyday life. And there are so many uses. Hand warmers are one such use. When the reaction happens and the hand warmers start warming your hands. And I already mentioned some things, even burning something like burning a matchstick, that's a reaction, and that has a use, because then we can put this gas stove on, which again is a form of combustion, and then we use that gas stove to cook, because that combustion gives away heat, and we cook. And car engines are another example. I mean, there are so many uses. Self-heating cans utilize exothermic reactions as well. And so these reactions, we see them every day, and they have tons of uses, guys. Now, what about endothermic reactions? So endothermic reactions take in energy from surrounding, as I already mentioned. And what is an example of endothermic reaction? Endothermic reaction. What's an example of endothermic reaction? One such example is thermal decomposition, when we have calcium carbonate turning into carbon dioxide and quicklime, as in calcium oxide. So thermal decomposition requires heat. We need to do this in a furnace. We need to supply a lot of heat in order for that reaction to even happen. It does not happen spontaneously. A lot of exothermic reactions don't happen spontaneously either. I will explain that in the next video. But the point is that endothermic reactions usually require a lot of energy to be put in for this reaction to even begin. And those reactions don't really tend to be flashy, because they don't give out energy to surroundings, so they don't actually look as exciting as exothermic reactions. So thermal decomposition, you just put in calcium carbonate, you take out calcium oxide out of furnace, and you can't see much happening in there. So endothermic reaction, that's one example of such reaction. And what are uses of endothermic reactions? I mean, endothermic reactions are much less common than exothermic reactions in our everyday life. Now, one use of endothermic reactions is, like I already said here, thermal decomposition, where we can create compounds useful to us that we need in an industry or in science, or for many other reasons. We sometimes have to do endothermic reaction to create such a compound. Now, another sort of more everyday use of endothermic reactions are sports packs. If somebody gets injured on a marathon, on an event, then you will often see paramedics going to that person and putting ice packs on them. Now, those ice packs, most of the time, those ice packs will not actually contain ice. They will contain two compartments with chemicals, and then when you mix them and you snap the pack, thereby you provide the energy to initiate that whole reaction. That reaction starts drawing in heat from surroundings. So it's an endothermic reaction, and it draws out the heat from surrounding, providing the coolness, the instant coolness that the sports injury packs provide. So that's one big use of endothermic reactions. So this is it for today, guys. Next video we'll be looking more in detail at what exothermic and endothermic reactions are, more into their profiles, then we'll discuss things such as activation energy, so make sure you stay tuned. And thank you very much for watching this video, guys. I really appreciate when you guys watch my videos. This is why I do it. And if you want to stay up to date on math, science, and some biomedical science videos, don't be shy, hit the subscribe button below. If you think this video helped you, give me a thumbs up. Thank you again for watching, guys, and see you next time.